Hey everyone, welcome back to the Wild Health Podcast. We're a genetics-based precision medicine company that's exploring all the big questions around holistic health, wellness, and performance optimization. If you're tired of the traditional healthcare system and want to sign up as a member with us, head over to wildhealth.com. And if you're someone who's looking for a high-touch, all-inclusive concierge medical experience specifically designed for executives and high performers, check out our premium program at wildhealth.com/premium. Now let's get into it. Hey Mike,
Hey Mike, how are you?
I'm good. How's it going?
Doing pretty good. Doing all right today.
We're we're continuing the theme of our at least on-air conversations, which is maximum nerd on the nerd dial. Like, let's take it all the way up. We'll try and make this. I promise for those of you who can tolerate the first hopefully 5 to 10 minutes max of nerddom that there's going to be a really practical summary of what we think may be going on in the world of protein intake. But we're picking up where we left off with MTOR. So go back to the
hmm
old to the prior episode if you want the big intro into the mammalian target of rapamycin. But we're going to pick up with sort of how does mTOR relate to muscle development and synthesis, and then we'll move on into how protein intake plays a role in regulating that.
That's the part that I'm super excited about talking about. But
Yeah.
let's talk about mTOR for a second, real quick, Mike. I'm just going to go over activators and inhibitors just briefly, just to catch people up in case you missed that previous podcast. mTOR is sort of like that anabolic signaling within the cell, right? So if you're activating mTOR, think about building muscle and getting huge. If you're inhibiting mTOR, then you're not building muscle. You're basically in this state of fasting or caloric restriction, and the cell is conserving energy is sort of the way to think about it. So things that activate mTOR, eating amino acids, particularly leucine, insulin-like growth factor, cellular stress, and insulin and glucose in your running through your blood. Those things are going to activate mTOR. mTOR can be inhibited at the same time by glucagon and cortisol, which are sort of like things that we see fasting, low growth factors such as fasting, calorie restriction, ketones in your blood. All those sorts of things are going to inhibit mTOR. So now that we know that, how does mTOR relate to muscle development and synthesis in the body? And the answer here is basically it's turning on multiple different genes that are associated with hypertrophy. So think mTOR activated, you've got protein synthesis, you're creating hypertrophy of the cells themselves. So anything like resistance exercise, weightlifting, all of those things are actually going to activate mTOR as well. And that's going to lead to an increased protein synthesis and therefore eventually muscle hypertrophy. And it does that by sort of increasing the synthesis of the actual proteins in the muscle cells, like the contractile proteins that make up the muscle fibers. We're going to increase the development of those through activating transcription from the from the DNA to build those cells up. You also see satellite cell activation. So satellite cells are basically these muscle stem cells that are involved in muscle repair and regeneration. And mTOR, when it's activated, is going to sort of activate those satellite cells themselves and increase the production of muscle or the muscle repair and also growth itself of the muscles just by creating new fibers, basically. So you're actually creating new muscle fibers as opposed to just increasing the size of the muscle fibers that you have. And then finally, activating mTOR is going to turn off muscle protein breakdown. So activating mTOR basically shuts off the body's natural ability to take muscle cells and eat them for energy, right? Like this is something that actually happens where you break down muscle protein and use it for energy. So mTOR inhibits FOXO, which is one of the genes involved in muscle protein degradation. So just like we talked about in the last podcast, sometimes while it's interesting to know the mechanism that this is happening by, really it's just like mTOR is anabolic. You activate mTOR, you think about all the anabolic things are happening in your body, whereas if you inhibit it, it's catabolic, and all the catabolic things are happening in your body. So that's sort of a quick few minutes on how protein is associated with muscle development and mTOR.
Yeah, I mean, I think the one thing that uh, just sort of like clicked for me is I know I've experienced this myself, and I know I've talked to patients about this. I'm sure you and I have talked about it before, but the concept of doing even just some resistance training while doing a prolonged fast, like that, that last mechanism you talked about seems like exactly why that would work to preserve lean muscle during a fast and preferentially shift your energy mobilization to fat stores as opposed to losing lean muscle during a fasting during a prolonged fast, right? You don't need to activate mTOR just through caloric intake. You can activate it to some degree just through resistance training, even in the absence of calories, and then probably not growing new muscle. In fact, almost certainly not growing new muscle because you don't have the substrate for it with the amino acids that you're not taking in, but at least inhibiting the degradation of the existing lean muscle.
100%. So, and what you're pointing out is, you know, through through diet, you activate mTOR presumably all throughout the body, right? Or you inhibit mTOR all throughout the body, depending on what you're doing to your diet, right? Like you eat amino acids, you probably activate mTOR all throughout the body, at least for some period of time. If you fast, you inhibit mTOR all throughout the body. But what you're talking about is, exercise and strength training probably activating mTOR in very specific places, hopefully just in the muscle cells, as opposed to in the entire body, right? So then now we're actually talking about we want to be catabolic for longevity purposes, right? But I don't want to really be catabolic to the point that I'm creating muscle degradation. So this actually gets into sort of an interesting topic around rapamycin, right? So rapamycin, obviously works on mTOR, it inhibits mTOR, but the studies that we've got on it, and granted, there's not a ton of them, it doesn't seem that taking rapamycin for longevity actually reduces muscle mass, which is super interesting because you're inhibiting mTOR all throughout the body when you take rapamycin. So the fact that we're not seeing muscle loss in the patients that are taking this medication is super interesting. And honestly, Mike, I don't have a great answer for why that's true.
Yeah, I mean, I would posit that folks who are interested enough in longevity that they would consider taking rapamycin, which, not a super dangerous medication, but not one without side effects either and without things to track and look after. Those folks are probably doing some strength training on a regular basis. So I
Yep.
wonder if there's a little confounding there where
Mm-hmm.
I like that concept at least of you're activating it locally in skeletal tissue as opposed to sort of a systemic activation or deactivation of mTOR.
I wonder how
All
much. I
right,
wonder
I
how
think
much
we've nerded
protein
out
those.
enough. Let's.
I was just going to say, I wonder how much protein those people are taking in too, right? Like people who are taking rapamycin for longevity, I would also postulate that those people probably eat a higher protein diet, which therefore might be getting more mTOR activation because of it. So it's just counterbalancing to some extent.
Yeah, yeah. I mean, it's hard to imagine that'd be interesting to pull those studies. Maybe let's put a pin in our nerddom for next time, and let's see if we can find out more about the populations where those studies were conducted on rapamycin not leading to lean muscle loss. Because if it's one thing if it's just a random sample of healthy volunteers, and it's another if it's folks who are living an overall healthier and or higher protein, more exercise lifestyle. All right. Rabbit hole narrowly avoided. Let's talk about protein because I think that we've talked about protein multiple times on the Wild Health podcast, and I think that the reason we have is that there is conflicting evidence on what the optimal protein strategy looks like for longevity. Right on one end of the spectrum, you've got um, sort of a camp of hey, caloric restriction and relative protein deficit, or not deficit, but low protein diets are linked to longevity. On the other end of the spectrum, you've got a very clear link between sarcopenia or muscle loss and increased mortality as we age. So maintaining lean muscle mass as we age, important for longevity and also important for health span, right? You want to get up off the ground on your own. You want to be able to lift up your grandkids. And then there's the fact that there's a lot of life happening in between, hopefully for most of us, in between today and our death. And do we want to be strong and functional in that time, or do we want to be sort of like really like skinny fat and just so that we can live a few years longer? And it doesn't even account for goals. What if you're, a competitive athlete, or you just really enjoy exercise and you feel like you want to be stronger? So this is why it's a complex topic. And I know you did a little bit of a dive here, so I'd love to hear your thoughts on sort of, protein in the diet. Like, and I know you can't give me this, but if you could give me just a TLDR, is it good for longevity? To have a high protein diet, a low protein diet, moderate protein diet, doesn't matter. I don't know, Mike. I feel
I,
like I don't know anything again.
So this is not the first time that I've deep dived into this because this research is really challenging in the sense that, one, it's all epidemiologic data. So it's of questionable quality in the first place, right? Like we're sending people surveys and saying, what do you eat on a normal basis? And then identifying those people who are eating higher protein and then trying to connect that to their risk of mortality over some sort of time frame, right? So like what I just described to you is just a giant mess, like there's not a lot of, you can't put a ton of confidence into this research. But in any case, there does seem to be some vectors of, directionality around this. And if I was going to give you a TLDR, it would probably be something like animal protein appears to generally have a more negative than positive effect on longevity, meaning that the more animal protein that you eat, the worse off you are for longevity. And that seems to be negated the older you are. And basically a higher protein diet when you're over 65 is, with as far as we can tell, without a doubt, a good thing. Whereas a
Mm.
lower protein diet before 65 is probably also a good thing. That doesn't necessarily mean that a high protein diet when you're under 65 is a bad thing. In fact, some studies have shown that non-animal protein diets that are still high in protein are still have a positive effect on longevity. So it's very convoluted. Let's talk about a couple studies just to see if we can kind of make some sense of this. So
Hey, just two quick things first, Mike. That was the world's worst TLDR that I've ever heard. I just want to call you out on that. I love you, but that has nothing to do. Like I'm just as confused as I was before you started. And two, just to give a real life example to why so many of these studies suck so hard is like, what did you eat 4 days ago for lunch? Right?
yeah,
Like
yeah.
this is how a lot of these studies are done, is like give us a 2 week retrospective food journal of what you ate, and like, was it 4 ounces of fish or was it six? I mean, it's just we're kind of, we're not working with high quality data. So I think that may, just want to echo that, I think that may play a large role in why we see studies kind of all over the map in terms of results.
Yeah. I think there's some consistent data in the studies. You can definitely find lots of studies that suggest that there is no effect of a high protein diet, but then there's also quite a few studies that suggest that there is a negative effect of a high protein diet on longevity. So, there's probably some signal there. It's just a matter of figuring out how much of a signal there actually is. So, one of my favorite studies, and I'm going to give another shot at the TLDR after we go over a couple of these studies and see if I can get it a little more succinct for you. But I'm just not sure it's like everything in medicine. It's not always black and white. So one of my favorite ones came out in 2014. This is a Walter Longo study. It came out in Cell Metabolism. The name of the study is Low Protein Intake is Associated with a Major Reduction in IGF-1, Cancer, and Overall Mortality in the 65 and Younger, but not older population. This is the study where I take that portion of the TLDR that I said, basically high protein when you're older is good. That I think is clear from this study. They looked at people who are basically under 65 and the people that are over 65, and then looking at how much those people are eating of high protein. And they basically found a 4-fold increase in cancer and diabetes mortality during the 18-year follow-up period for those people that were under 65. So those are people 50, I think they only looked at people 50 to 65. So basically under 65, high protein, higher risk of cancer, diabetes, mortality. That was fairly clear. What's interesting though is when they looked at patients who were getting that high protein diet from plant based, that basically abolished or attenuated all of the effect of the protein. So if you were eating a high
Hmm.
protein plant based diet, you did not have the fourfold increase in cancer and diabetes mortality during that 18-year follow up, which is super interesting. The the other interesting thing is that when you're over 65, higher protein, independent of source, whether it's from plant or whether it's from animal products, was associated with a reduction in mortality. So when you're over 65, so it's like basically you're 64 and 364 days, you want to be eating low protein, right? And then that next day, all of a sudden you want to just eat all the protein you can. It's that clear. So obviously it's not that obvious,
Cannot
but there
cannot
is an
wait for my 65th birthday.
yeah, there's definitely there appears to be an inflection point where at some point the benefits of not being frail outweigh the negative effect of increasing cancer risk or diabetes or cardiovascular risk that you see from higher protein diets when you're younger. So I guess the way I take that and what I say to my patients with that is something to the extent of like, look, the data suggests that when you're younger, it's probably better to eat, more vegetables, get more of your protein from your vegetables, and not necessarily, crush the protein. Now, the challenging thing to that, Mike, is that really true? I mean, we're talking about all comers in this study. So, I suspect there's a lot of metabolically unhealthy people here. We're not talking about how much, simple sugars they're eating. So are we talking about people with, insulin resistance, and people with insulin resistance who are eating high protein? Those are the ones that are maybe making up the majority of the cardiovascular disease risk, the cancer risk, and the diabetes risk. And we're not necessarily talking about the young and healthy athletic population that in these studies. So we gotta take it with a grain of salt, because I'm not sure it's applicable to the type of patients that are interested in some sort of longevity research in the first place, right?
Yeah, I mean, and on top of insulin resistance, what about saturated fat genetics, right? I mean, if you're talking about folks with PPAR alpha, PPAR gamma, FTO SNPs, ApoE SNPs who are eating a lot of animal protein, and there's a fair amount of saturated fat coming with that. The risk for insulin resistance, dyslipidemia, diabetes, obesity is going to be significantly larger in that group than if you're talking about somebody or a population without those same genetic markers. So, just another layer of complexity to trying to study this at a population level is, our sort of go-to it depends when people ask us questions about their health. I think it really does, right? I mean, there clearly are patients who I'm taking care of who seem to be able to tolerate all the saturated fat in the world and come to me on a near ketogenic or carnivore diet with absolutely pristine biomarkers and low body fat percentage, and they're doing great. And granted, there's always going to be some issues, and these are things that need to be followed. But I think these aren't precision medicine studies.
Mm-mm.
These are population studies, and just one more. And I don't know if it's a confounder, but maybe one more step zoomed back, zoomed in, and we're kind of not seeing. I'm not sure where my analogy is going here, but like what's good for the forest might not be good for that one tree.
Sure.
So
Yeah.
it's definitely a challenge that we also face here. That's largely unaddressed, right? I mean, we don't see that. I have yet to see anything on a well conducted study looking at protein intake, animal, plant, or mixed, with accounting for genetics
Yeah.
and accounting for how people metabolize saturated fat.
Not a long-term mortality outcome study. No, it's interesting. You mentioned
Yeah.
saturated fat, which, we've identified, a long time ago with Wild Health, that they are patients who respond differently to saturated fat, and it significantly increases their lipids, and presumably that's increasing their cardiovascular disease risk. So we think there's this correlation between, high fat animal protein and dairy, and cardiovascular disease. But that's not just the saturated fat effect is not just for cardiovascular disease risk. We know it's also for diabetes and insulin resistance, right? So there's the FTO SNPs that are
Yep.
associated with an increased risk for insulin resistance and diabetes development. with high saturated fat diet intakes. And what's interesting is you look at the Rotterdam study, which is another one of these studies published in 2020, another epidemiologic study. They looked at like 7,000 people who were over 45 years old, and they found that there was a significant relationship between a higher intake of animal protein, specifically from meat, dairy, and fish sources, that was associated with higher insulin resistance and risk of prediabetes. And presumably, that's associated with those FTO SNPs and other genetic predispositions for increased insulin resistant risk in high saturated fat diets. So, it'd be great. I mean, I'd love if we saw a precision medicine study looking at this and saying, based on these genetics, you can or cannot eat animal protein. And obviously that's how, we're practicing medicine at Wild Health, but that's not how the rest of the world is practicing medicine right now. So if you take all comers, what you end up with is there's enough of a signal that it appears that animal protein specifically, and which is likely in my mind due to high saturated fat content, is associated with increased risk of mortality, at least earlier in life, due to predominantly cardiovascular disease risk, but also there's a signal for diabetes and insulin resistance as well, which is super interesting. But like I said, that's still confounded by the fact that we're taking all comers, and we don't know if that's true for the highly athletic or fit population, or the population with very low levels of insulin resistance. It's very possible that the combination of high protein and high insulin resistance is enough to create a signal. Right. So those people with a high insulin resistance who are eating high protein diets are creating the majority of that signal. And the people who are otherwise metabolically healthy can eat higher protein and not have the same effect. So lots of up in the air with this topic, unfortunately. But I think it's worth saying that there's definitely a signal, at least for longevity, that the higher protein diets when you are younger, if they come from animal sources, are more likely to lead to mortality. And then that is abolished when you're older, because there's an advantage to the higher protein in reducing frailty and increasing muscle mass. That's my TLDR.
Yeah.
Is that good enough? You want me to try again?
I think no, I think it's good enough. I think I think the thing that's unsatisfying about it's way better than the first one, just for the record. I mean, we can roll back the tape, but it's way better than that first one. The thing that's unsatisfying about it isn't your fault. Is that's true for a population, right? And we
Yeah.
talk about
Right.
this in lots of ways with our patients, and we really try and dial down to what's right for them. But none of these longevity, all cause mortality, cardiovascular mortality, cancer incidence, cancer mortality, none of these are like these dramatic tenfold differences, right, in these studies
Mm-mm.
when you break people down based on how much protein they're taking. So you really could imagine, like, I don't know, just I don't know the incidence of homozygous risk SNPs at PPAR and FTO, but I know that definitely at least half of my patients have either heterozygous or
Yeah.
homozygous risk
Yeah. That's about right.
at those gene loci, right? So,
Mm-hmm.
and then we know sort of ApoE3/4 incidence and ApoE4/4 incidence.
Yeah.
Um, it wouldn't be surprising to me if if you did a subgroup analysis of the high protein group and stratified people based on their genomics, if you had those sort of high risk genomics accounting for 80% of the increased mortality that you're seeing, that wouldn't surprise me at all, because we're not looking at these giant differences in those groups. So I think there's a
Yep.
big population difference. I think I do like the TLDR over 65. It's more important to maintain lean muscle. You're in a battle to fight sarcopenia, and you should be eating a high protein diet when you're over 65. But it almost feels like um, a gentler, more lifestyle based recommendation than like, oh, you're 95 years old and you want to start smoking, go for it, right?
Yeah.
I
Right.
mean, I'm not
Right.
saying you should, but it's this, like at what point, there's clearly no health benefit to smoking, but so it's not a perfect metaphor, but the idea of, you know, if high animal protein, and I suspect with a genetic risk profile, leads to an increased risk of dyslipidemia and insulin resistance and all the diseases that come along with that. If you're starting it late enough in life, you're probably not going to see those effects.
Right.
You're
That's
you're
the whole
gonna
point.
die of natural causes or some other cause prior to that. So I think that
Yep.
I'm on board with your TLDR. I'm still
Okay.
not like
Right.
sure what to do for myself. Actually, I am, because I have my genetics and I have a good doctor. But I'm not sure how to answer that question for somebody just you know at the kid's soccer game who comes up and goes, "Hey, I was listening to this podcast and I'm wondering if I should eat a lot of protein or not eat a lot of protein." I think the answer is still, for an individual patient or individual person who asked that question, I think the answer is still it depends, until you've
Yeah.
got a look at their genetics and their biomarkers.
Well, I mean, I think you can say, at least based on my interpretation of the data. So if I look at the data, it looks like you can have a higher protein diet if it's plant based, right? So I think it's fair to say, like, sure, eat high protein,
Yes.
just get the majority of your protein from plants, right? Now that can be really hard. That's not always super easy to do. It's easier now that there's pea protein supplements and things like that, but that appears to be true, right? Whereas the question
Yeah.
remains,
Yeah.
if you want to eat high protein from an animal source, that's where I think it really depends. And sure, it depends, I'm sure,
Yeah.
when, what your goals are, right? If you're, an elite athlete, then I think, realistically you need to be eating higher protein. But, if you're just a, random Joe Schmo, then I think the real TLDR is get your protein from plants, unless you're
Yeah.
older,
And
then it
just
doesn't
to
matter.
make the TLD, yeah, unless I was going to say, unless you're at the soccer game and it's the 70-year-old guy who asks you, in which case eat lots of
Right.
protein.
Yep.
But the one caveat on the plant protein is, you got to be careful where that plant protein is coming from, and we really would never have had to say that maybe 10 years ago, but a lot of the sort of fake meats, fake cheeses can be just laden in saturated fats, and are so uber processed that there's some of the unclear what the real, if you're tilting towards a health benefit or a potential health risk by eating and no offense to Impossible Burger, but like eating an Impossible Burger every day for lunch, I would not recommend that as a healthy strategy for someone overall, kind of regardless of what their genetics or their labs look like. So, getting lots of protein from plants probably a great way to go, but it takes effort, as you and I both know, having been
Yep.
plant based at different parts of our lives. It's a lot of work.
Yep. It's not easy. Not easy for sure.
You
And I agree with
know.
you. I mean, basics still apply. You've got to be eating healthy food, not necessarily, processed food just to get your protein sources. So that is some complexity there. So I just find this such an interesting topic. It's because it's something clearly we don't have enough data to really, have a true TLDR or a statement that we can feel 100% comfortable about. But it is super interesting because there appear to be so many other benefits of protein, like for example, reducing carbohydrate intake, the satiety effect that you get from protein. So it's interesting that there could be this mortality negative effect from higher protein diets. But when you look at mTOR, which is the whole reason we're talking about this in the first place, it starts to make a little bit of sense, right? Like if I'm constantly triggering that anabolic mechanism, I'm flipping the anabolic switch in every cell, like, every single day, because I'm eating, I don't know, 160 grams of protein a day. Then all of a sudden it does start to make a little bit of sense. Like, if you're running the engine hot, always running the engine hot, then you're going to have problems if you're never cooling it down. So super interesting topic.
Yeah, just for the record, even though your first TLDR really was abysmal, I didn't expect you to be able to give a good one, because there isn't one, and I think that's sort of the point here. Well, the point is me getting a chance to rib on you because it's fun,
Yeah.
but the real point is, you get these the studies in the popular media, or health experts out there, and health enthusiasts who will tell you, um, we have the right recommendation. You should be eating, 0.8 to 1.2 grams of protein per ideal body weight, or you should be eating 1.5 grams of protein per pound of ideal body weight, or you should really not be eating protein because studies have shown that lower protein intake leads to longevity. And I think if you hear such a simple distillation of this topic, I would just
You're being lied to.
really question. Yeah, I would really question the validity of that for you personally. I
Yeah.
think it's one thing when somebody can really, and I'm not trying to toot our own horn. There are other, places I'm sure that people look at deep dives into genetics and labs, but like until you really know how your body works, I don't think you're going to have a great off the shelf or off the podcast uh, answer to what's right for you in terms of protein intake and longevity. So I kind of set you up there for the TLDR thing. Sorry, buddy, but I think it was a great way to kind of highlight how challenging this concept can be. I mean, I was telling you, I just got an email blast earlier today from a company that had sort of sent out an informational email about protein and longevity, which was aptly timed since we were already scheduled to talk about this today. And one of the studies that is cited there is a study from BMJ, so British Medical Journal from 2020, on dietary intake of total animal and plant proteins and the risk of all-cause cardiovascular and cancer mortality. And it's this giant systematic review of, something ridiculous like 113,000 deaths in a follow-up period of 3.5 to 32 years. And they break it down, and as you look at sort of, is a high protein diet good or bad for for mortality, cardiovascular mortality, cancer mortality, the movement around the zero, around it has no effect on these studies, is dramatic, right? I mean, there's some of these studies show, yeah, a higher protein diet's going to kill you, and some of them show, a higher protein diet's definitely going to make you live longer, right? I mean, it's not even that like everyone's struggling to find an effect; it's that the effect is showing up on both sides, and there's clearly confounders and other issues going on here that are clouding the picture. So it is a cloudy picture, and I think the answer is, do your best to find out what's right for you, but there isn't going to be a TLTR for should human beings eat more protein when they're under 65 years old. There's probably if it could be plant protein, sure, and over 65, yes, and under 65, maybe, right? Maybe a high protein animal diet's okay for you. Yeah.
Yeah. Maybe is all you can say.
Yeah.
Yeah, maybe, or maybe it's bad. Yeah. Yeah, I mean, this is just another classic example in medicine of how we try to find these situations where there's a clear culprit or a clear effect from a single variable, and so rarely in life does that actually happen, right? I mean, it's like, sure, sometimes that variable is bad, but sometimes it's probably good too, right? It depends on what your metabolic health is, what your fat intake is, what your carbohydrate intake is. It might depend on what your genetics look like. Like, you can't just, we assume that you can just pull everybody together and then find find the common directionality, right? But what we're seeing here, the fact that some of these studies have a negative effect, some have a positive effect, is that it's way too variable to be that simple. So we're going to have to attack this problem with a little bit more precision rather than try to throw a huge study of 113,000 deaths at it and come up with a solution.
Yeah.
And that's what it's going to have to be.
It's interesting. You remember way back in the day, I don't know if they still believe this or teach this in med school, but even something as simple as smoking, which, clearly is terrible for you in every number of ways that you want to measure, whether it's cardiovascular, blood pressure, cancer, lung disease. There was a subgroup of irritable bowels, inflammatory bowel disease patients who reported a decrease in symptoms with tobacco use. So like, even there, like, not that shifted it to they should smoke, but even there, it's never as simple as we want it to be. So and far more complex here. I think the TLTR on smoking is don't smoke. That's an easy one. The TLTR on protein is a lot more complicated.
Yeah. That one's easy.
No.
Yeah,
still
unless you have IBS. Maybe.
All right, buddy. Listen, thanks for this. This was super fun. I don't know that I don't know that we're going to get a clearer answer than what you outlined today. So for all the joking about your first stab at the TLDR, I think it's a really good one.
I think it's the best we got right now. Hopefully we get more research later to figure this out, and then we can get a little bit more specific for people. But as far as we got now, that's as good as we can do.
Love it. All right. Thanks, buddy.
Thanks for listening to the Wild Health Podcast. If you found it helpful, give us a 5-star rating and write a review on iTunes. It really helps the podcast, and we greatly appreciate it. If you want to be a client or you want to work with us, go to wildhealth.com. Thanks again.